Okay, so today we are back in activity 5.2. And activity 5.2 is on page 63. So right now, go ahead and open up your books to page 63 as we go over our learning targets for the next couple of days. So for the next couple of days, we're still focused on our original LEQ. And that original LEQ is how can I define, recognize, and compare numbers in multiple representations. What we're going to look at today is yesterday we already looked at approximating an irrational number. So we're going to continue doing that again today. The other thing we're going to do is we're going to work on comparing and ordering irrational and rational numbers. So we're going to look a little bit deeper on finding rational and irrational numbers between two numbers. So this here is actually on page 64. So if you go ahead and turn the page from that from those two learning objectives, go to page 64, and I want to switch this over and I want to show us a number line. So this here is an interactive number line. You can see you have your integers 1, 2, 3, and 4. I can zoom out so that way you can see like you have positive numbers and negative numbers. And as we watch these scales on the number line, we're going to zoom in closer and closer. So here, 0, 1, 2, 3 looks like a number line. So now in between 2 and 3, I've got tenths places. So now in between each tenths place, I have hundredths places. So this would be like 2.41, 2.42, 2.43. And then if I continue to zoom in, I'm going to make my screen smaller. I now have thousands places. So this would be 2.411, 2.412, 2.413. And again, if you go on and on and on, these numbers never end. So you can always come to a more specific number or a number with a more another place value on your number line. Okay, it never stops, it never ends. So what happens though is that some numbers you can always say like, oh, well, that's over, I can put that over 100th. So that's a rational number. But some irrational numbers, they just continue on and on and on and on that number line. So we're going to go ahead and we're going to talk a little bit more about the differences between rational and irrational. So right here, it says, give an example of a rational number between the following two numbers. So if I have my number line and I have 2 and I have 2 and 1/10, I want to know what numbers are between those two numbers. So this number right here, even though it says 2, I can actually think of it as 2 and a 0 in that place value. So now if I wanted a number in between these two numbers, an example would be like right here. So that number right there would be 2 and 5/100. Okay, it's rational. It ends. Even if I said 2 and 51 thousandths. If I said 520 10 thousandths, 2 and 520 10 thousandths, because it ends, it's still rational. So an example in everything I write, you should write. An example of a rational number would be, okay? Then an example of an irrational number would be anything that has no pattern and continues on and on and on, as denoted by the ellipses. So I could take this same number, and if I said that it continues on and on and on, there's no pattern to that number already. So just by saying that it continues on and on and on, that makes it irrational. I could have named a different number and made it irrational, but that one makes it irrational. So right now, what I want you to do is I want you to pause the video, and I want you to talk to your group and work through B and C. Then I want you to explain number 2. Explain why is it always possible to find another number between these. And I want you to think back to this number line. So let me go back and make this normal again. So think back to this number line. What happens as we continue to zoom in on a number line? What happens as we go more and more detailed? So pause those two things, talk to your group, and then come back and we will move on to the next activity. Okay, so now we're going to go ahead and we're going to go over those answers from the Try These A. Your answers may be different, but I want to make sure that you have answers down. If you don't have answers down, it is not beneficial for you to just copy down these answers. It is beneficial for you to understand this. This is not a grade, but you are responsible for this information later. So here are the answers that the textbook had. These are just a couple examples. Your answers could have been very, very different. I do want to make sure, though, that your numbers, like see how that 3 and that 3 are the first three numbers because it has to be in between 3/10 and 4/10. So make sure that you have like that first tenth decimal place in both of those should be the 3. Same thing here, because it's between 10 and 6/10 and 10 and 7/10. All these numbers have that first 10 and 6/10. So go ahead, pause, check your answers. And then I want you should have a worksheet in front of you that looks like this. All right, again, going back to our LEQ, we're going to work now on comparing rational numbers in multiple representations. So there's two ways that we can compare numbers. We can compare them using what we call inequality symbols, or using a number line. And we're going to compare them right now using both of those two things. When we're talking about our inequality symbols, so like an equal sign is not an inequality symbol, but an equal sign represents that they are equal. They have the same value. Our inequality symbols are symbols like this. Do you remember what these symbols right here, what they mean? Turn and talk to your group. What do these 4 symbols represent? What do they mean? When you're ready, push play. All right, great. So now we're going to push play. So this symbol right here is a greater than symbol. This next symbol, that little line underneath of it, is part of an equal sign. They just brought it right over. So this would be greater than or equal to. Okay, and then you guessed it, the symbol over here is the less than symbol. That little narrow point, so this is less than. And then this one right here is less than or equal to. Okay, so we're going to use these symbols. All right, now looking at the bottom of the page, and it doesn't matter if you have Form A or Form B, this first page is the same on all of them. All right, so now we have these 1, 2, 3, 4, 5, 6 numbers. First thing I want to do is I want you to highlight any irrational numbers. Okay, so if it's an irrational number, I want you to highlight it. So put a highlighter over irrational, reach in your bins, and then highlight any irrational numbers. Once you have them highlighted, go ahead and pause right now. And then once they're highlighted, you're going to push play. Great. You should have highlighted the square root of 5 and the square root of 17. Those are our two irrational numbers. So now we're going to represent those irrational numbers in a different way. So when I look at these two numbers, the square root of 5, I want to approximate it using rational numbers. So I know that the perfect square before it is 4, and I know the perfect square after it is 9. My base of 4 is 2, my base of 9 is 3, so I know that the square root of 5 is somewhere in between 2 and 3. 5 is very close to 4, so I'm going to approximate this at approximately 2 and 1/10. 2 and, or I could say 2 and 2/10. Either one of those would be good approximations. For the sake of this, I'm just going to go ahead and I'm going to use 2 and 1/10. Okay, same thing over here for the square root of 17. I want you to go ahead and I want you to try to approximate the square root of 17. So hit pause right now, and then I want you to push play when you're ready to check your answer. Okay, great. So the bases, the perfect squares before and after the square root of 17 are the square root of 16 and the square root of 25. The base of the square root of 16 is 4. The base of the square root of 25 is 5. So 17 is closer to 16, so a good approximate here would be like 4 and 1/10. Okay, now I know that the square root of 9 is a rational number. What's the base of the square root of 9? That's right, it's 3. And then I have my 5 and a half. Okay, now I have two other numbers. So when I'm looking at this, I see that 1, 2, 3, 4 of my 6 numbers are in decimal format. So I'm going to go back to what we did in activity 4.1. I'm going to convert my fraction to a decimal, and I'm going to convert my percent to a decimal. Right now, I want you to pause, and I want you to make those two conversions with your group. When you are ready, check your answer and push play. Great, so you should have had 75 hundredths for 3/4. That would be 3 divided by 4, numerator divided by denominator. And you should have had 1 for 100%. Okay, so now I'm going to compare these 6 numbers using a number line. My smallest number is 75 hundredths. My largest number is 5.5. So I can count by 1, 2, 3, 4, 5. I can actually count by quarters. So if I make this 0, which it doesn't have to be 0, it just makes sense because my smallest number is close to 0. That would be a quarter, a half, a 75th. This would be 1. And I have to count my numbers evenly. I can't make this space right here 1 and then put 2 because my intervals wouldn't be even. So again, this would be 1.5, 1.25. This would be 2. 1, 2, 3. This would be 3. 1, 2, 3. This would be 4. 1, 2, 3. This would be 5. So I'm just going to extend it out just a little bit. And that would be my 5.5. So now I'm going to go ahead and I'm going to write my original numbers because I want to compare these numbers in their original form. So I'm going to write them on the number line as they were originally written. So my first one right here, the square root of 5, I'm approximating that at 2 and 1/10. So that would be approximately right there. So I'm going to go ahead and write the square root of 5 and put it right at this point. That's approximately where it is. And then 3/4. So 3/4 is the same as 75 hundredths. So I'm going to write my 3/4 right there. Same thing. Square root of 9 can also be represented. It has a different representation that's the equivalent of 3. So it goes there. 5.5, I represented it in the same form. I had to extend my graph, so the 5.5 goes there. Square root of 17, its different or multiple representation is 4 and 1/10, so it goes right there. And then 100% has the same value as 1, so it goes right there. So I've now compared my 6 original numbers using a number line. I want you to pause the movie right now, and I want you to turn and talk to your group on how we did this. Go. Great, welcome back. So now we're going to finish answering our LAQ, and we're going to do one more thing. We're going to represent, or we're going to compare these numbers using our inequality symbols. And this right here, this should say 100%. I'm sorry about that. I'm sorry that I forgot my percentage symbol. So it's 3/4. So 3/4, is that greater than or less than or equal to 100%? It is less than. So I'll put in my 3/4 is less than. The small portion of that symbol is closer to my smaller value number. So it's less than 100%. Square root of 17. So my square root of 17 is 4 1/10, and that my other number is 5 1/2. So this, once again, is less than, because this value right here can also be represented as 4 1/10. So when I get them in the same format, right there, same format, this one represented as a decimal and not as a square root, then it's still less than. All right, and my last one, my 5 1/2, so that's written as a decimal, and then I have the square root of 5, which is actually 2 1/10. So for this symbol right there, I'm going to use my greater than symbol. Okay. Great. So right now, I want you with your group to work on the back of the worksheet. Then I want you to check your answers in Schoology. They are loaded into an Activity 5.2 folder, and the answer keys are provided. Don't do this until after you've done the back of the worksheet. Only do this to check your answer. Again, this worksheet isn't graded. It's just used as a learning tool for you. Please, as always, raise your hand if you have any questions. Okay, please raise your hand if you have any questions.